Hi there, I'm John from CNCKing.com, and today we'll take a look at this piece of scrap that I made with my CNC router. This project has actually been a long time coming. I've been wanting to make custom wooden banks for a very long time. I just never got around to it because I keep having custom jobs and they have priority over everything else. Now I finally got the bits and all that stuff sorted out. And I said, well, I'll start, producing it and see what happens with it. Now in this case here, these are about what, 1, 2, 3, 4, 5, about 12 banks. And they're all supposed to come out really nice. This is red oak, so it's laminated. So the first step after I come back from the lumber store is actually to chop it up in smaller pieces, as you can see here on the edge. And the reason why I did that was because this is a lot stronger than having just one solid piece of red oak. And it's also stronger than just having, large laminated pieces. So every one here is roughly around 2 inches. So 2 inches, 2 inches, 2 inches, 2 inches. And they're alternating the grain. So again, that just gives the banks a lot more strength. Because children will be playing with this and it can fall off a shelf and I don't want it to actually break. In all the years of doing woodworking, I never actually did any lamination myself. So the first thing I thought about was I want all the sides of the board to be completely flat. So that's what I'm doing here. I'm using the CNC router to flatten the top and the bottom. And then later on in the process, after I cut them all into slices, I'll router the other 2 sides that end up coming from that. The nice thing about that is I have very, very straight boards and they're parallel. So when it comes to the glue up, it's very, very easy. I also don't have to clean anything up because basically the router is cleaning up all the surfaces as it's doing the routering. The one drawback from doing this is, as you'll see, I waste a lot of wood. But again, this is just the first time I do this, so I just want to have absolutely perfect boards to work with to make this first set of production banks. The material I'm using here is a little bit over 2 inch thick red oak, and by the time I'm done all the work that I've done, it's roughly 1 3/4 inches. So I do lose quite a bit of wood, but that's the way you do it because you don't end up with straight boards that are roughs on. You end up with boards with lots of warping on them. I could technically use the planer to clean some of these things up, but I can't get the whole board to fit in the car. So it's just easier to have the mill chop them up in smaller pieces. And then from then on, I do the lamination that I need to do. So here what I'm doing is I'm cutting them up. It's roughly 2 inches, every 2 inch interval. Now I am having issues for some reason. The red oak really wanted to bind on me. So sometimes I had to go over it twice to pick a cut line because it was just as soon as you cut it, the stresses in the wood would work out and then pinch against the blade. So after the laminating process, which involved a lot of router work because I don't have a jointer here in the shop, the next step was actually just cutting out and getting the proper bits. Now originally, I use a lot of 3/8 bits, as you can see here, and they work wonderfully for the work that I do. But in this case here, I needed something a lot bigger. So let me show you a comparison. So this is generally what I use here in the shop, and this is what I used for this job. So this is a 1/2 inch. The reason why you want a 1/2 inch is because at the end of the day, you're doing a lot of clearing out of material. And if you use a 3/8, well, you're spending a lot more time clearing out that material than if you use a 1/2 inch. Now, yeah, I could use a 1 inch and, even just sort of mega bits, but the problem with using a bigger bit is you end up losing a lot of resolution. So for this, it probably wouldn't matter. I'd probably get away with using a 1 inch bit. But for some of these kind of things, I wanted to show the small details. And the only way to show that is to go with a small bit. So it's sort of like, do I go with a small bit, show more detail, but have more production time, or vice versa? So it's a bit of a game you sort of play with the machine and the settings. Now it might seem like I have every tool in the world, but I really don't. I never had a need at all for a jointer before. But this project really brought up to light that, it's time to get a jointer here in the shop to do this kind of wood, this kind of project. Now the problem with this process here is that I'm using the router to flatten and make all the boards parallel. But the bottom side is I can only go as deep as the least thick board. What that means is I might have all these boards that say 2 inches, then I have one board that's 1.5 inches because it's cut from the edge of the board. So that means I gotta do them all at that thickness. Now if I joiner, it doesn't really matter. They can be thicker and thinner. They'll all be flat, not parallel, but flat. And then I wouldn't waste so much material. But again, it's just the first time I do this, so I think, you might as well do something that takes a lot longer and figure out all the kinks in the system. And then after that, work out backwards what you should have done better next time around. Now what I'm doing here, you can see the board at the far left. You can see that one there is still looking really rough. So that's what I meant. I have to keep shaving all the boards until I shave that last board out. And that's what I just did just there. So one final pass, and then I flip the whole thing around, and I do the whole thing on the other side. So I have really, really nice boards. So this is just fantastic to work with, but it comes at a cost of lots of material being shaved everywhere. Now I don't really care about the edges right now because I'll be putting them in the router. So what I'm doing is I'm gluing them up as best as I can, and I'm using a roller to distribute the glue. It's just a better use of material that way, and then you squish it all. I found with glue ups, you don't really need to just drench everything. I put a lot of glue, as you can see, but I don't have it leaking absolutely everywhere all across the shop, because that's wasted time. Now I don't care if the glue dries here, because the router will just shave all that stuff right off anyways. So of course, before you start a production run, the first thing you think about is, I'll just do a quick test before I do the whole job. And that's what this little circle here was meant to represent. And it actually worked really well. I worked out the speeds and feeds. You might notice in the video there's a lot of jumping of the router head. And the reason for that is because I'm going too fast, so the router just can't keep up with how much material it has to eat. As a result, it just starts chattering everywhere. And I knew that was going to be an issue because I've never used bits that are that big to go this deep to do this kind of work on red oak. Red oak is a very hard and dry material. So after I got all that sorted out, it looked sort of okay to me. And then I did this one here. And again, this one looks pretty good to me as well. But in hindsight, you can see that there are some issues. The first thing, look at it closely, you still see some chattering at the bottom of it. And the reason for that is because in the design file, I was so focused on so many other issues that I wanted to fix while doing this, I completely forgot to give two different depths, because I'm using two different router bits. So one is just hogging this material as fast as it can. The other one comes over it and just cleans everything up. So for here, it was hogging everything out, which is great. Then the other bit was coming in at exactly the same height and doing basically nothing because both bits were going at the same height. So you have the one that's removing material up here. Let's say this is the depth of the bank. Then the other one you want to go a little bit lower, a little bit more to the sides to remove the material to give you a nice finish. The reason why you want a nice finish on these things, because you don't want to spend hours and hours sanding them, especially if you're doing production work. Sanding this kind of stuff could just kill doing a job like this. It's just a tremendous amount of sanding, and it's not anything straight either. So there's like small little inner corners and stuff like that that you have to contend with. Now for the final step, yes, I'm flattening both sides all over again. So that's where I say I'm wasting a lot of material flattening and reflattening things. So the next time around, what I'm going to do is just flatten two sides, and we'll see how that goes. But I think flattening three sides will be the best way forward in the future for this process here. But as you can see, everything's glued. Everything looks fantastic. It just glued amazing. I was really surprised at how well the router flattens all the edges that I need to for this project. Now this project, for the design process of just the banks that you saw here, that was probably a little over a week of work, because I'm basically using 4 programs to do everything in this project. So you have the font, and you have to optimize the font for the router, and then you have to sort of everything nested on the piece of wood, and then after that you can finally cut it. So what happened here is I kind of screwed up because I did all the updates on the first 2 programs, and I made a mental note to upgrade or update the 3rd program that was actually cutting these things out. Because originally I was going to use a 3/8 bit to do all this stuff, but then I realized, well, that's going to take forever. So I ended up using a 1/2" bit. But I just forgot completely to update some things. So I updated the bit, but I forgot to update the design. So what I'm doing here is doing tests on 2 areas to make sure the design works. And it's been so long since I did the design process that I completely forgot about the edge thickness. So that's what I'm doing here. Everything looks fine visually. So okay, cut everything out and see what other problems I might possibly have with this. And the reason why I'm stopping and starting over and over again on this here is that I'm optimizing the feeds and speeds. Red oak is very, very hard, And what you want to do is have a router produce a nice clean edge, but you're fine tuning the speed of the router and the speed of the spinning and all these kind of things at the same time. So I had a lot of my head going on during this time here just to produce the bank. But again, I noticed something was wrong when I was doing the edges, when I was cleaning them up and doing the edges. I'd actually hear resonance because the thickness was so thin, it was almost like a musical instrument. So then I knew there's something definitely wrong going on here. And then I just let it keep going because there might be other issues with the cutting process that I didn't think about. So there's no point stopping here and throwing it out. Just let it finish the whole job, and then you'll find other issues that you need to fix next time around. And that wastes a lot less material than stopping and then doing another run and then wasting even more material because there's something at the last step that you screw up on. So were there some other issues with this file? Absolutely. The biggest one you'll probably notice is this is the thickness that I wanted to have. I'll show you a close up. So this is the thickness that I want to have on all the walls. And this is the thickness that I have. You notice there's a huge difference. And the reason for that is because the way I programmed it, I went over the wrong thickness of the files. I basically have to use 4 different programs to make this. And I updated the first 2 programs to be the right thickness. And I forgot to update the 3rd, and the 4th one is the one that actually cuts them out. So when I did this, I didn't notice it because that's the right thickness. When I saw this one here, I go, well, that looks kind of weird, but okay, maybe it's just the design. I forgot something. But then all the other ones that I noticed right away that the thickness was wrong. So the wall thickness is wrong. I also had the wrong depth for these things here. You see a small little margin right here. And that's because I had an offset that was a little bit off on the wrong bit. So you want offsets to remove material, but I had the offset on the wrong bit, so it wasn't actually cleaning anything up. So other than that, it came out actually pretty good. A couple of things I ended up not doing. These holes here were actually to screw it down onto the router bed. And I ended up not even needing to do that at all because I had a vacuum table and it sucked it totally fine. So I didn't have any issues with holding that down. So what am I going to do next with this project here? I think I'll just chop it up for the fire pit, and then I'll do it all over again using the proper wall thickness and all the lessons that I've learned from this job here to the next job, which is basically the same thing, but cut properly this time, hopefully.